So in this last part of the module, what we're going to do is pretty much redo things in 5.2 and 5.3, but we're not going to have any technology. So we're going to take the calculator at your hands, and you'll see how I can phrase the questions to try to help you out where you don't need the calculator. We can just use the theory that we've learned and just kind of do that. So in the first one, I've got a function, and I'm showing you its graph. So the function's x to the fourth minus 4x cubed plus 5x squared minus 4x plus 4. And we want to use this graph of the function. So I'm kind of giving you the graph without the calculator. Use it to find all the roots. And again, roots means zeros. So let's find all the zeros. Well, how many zeros we're expecting are 4, right? So we're expecting 4 zeros, but when I'm looking at this, I only see one of them being shown, and it looks like that's happening at 2 with multiplicity of 2. So that means the other 2 I'm expecting have to be of the complex variety. So to find them, I need to start doing my division. So we're essentially going to divide by x minus 2 not once but twice. So here's the first round. So listing my coefficients. We got that. Doing my long division, we have 1, and that's a 2, and that's a negative 2, a negative 4, which is a 1, and a 2. Oops, let me just make sure 1, negative 4, 5, negative 4, and that's a 4. All right, that's a negative 2, negative 4, giving us 0. Couldn't read my own writing for a while there. And not only is x minus 2 one factor, but it occurs again. So we're going to do it again to that guy. So 1, negative 2, 1, negative 2. So carry that down. That's a 2, and that gives us a 0, 0, 2, and 0. So we got a remainder of 0. So at this stage of the game, our function is x minus 2 times x minus 2, and what's left right there is x squared plus 1. And so as expected, right, the remaining zeros come from that guy, and when I solve it, I can use the square root property, and we get plus or minus I. And we were expecting that. So I is a solution, negative I is a solution, and 2 is a solution. But to account the fact that there's 4, right, this guy occurs twice. It has multiplicity 2. So 1, 2, 3, 4 zeros. And they just asked for the roots. I gave them the roots. We're done. Okay, so that's how I can get around using the calculator. I'll actually just give you the graph, and then you just know how to read the graph and gather information from it. The next problem, the number f of 1 over 3 is 0 to the function. Now again, by theory, this means that x minus 1/3 is a factor. Okay, so there's the theory working for us. If the polynomial is given by this guy, 3x cubed minus 4x squared minus 2x plus 1, use this info to help you completely factor the polynomial. So again, what we know about completely factoring is because we have a degree 3 here, right, there should be 3 linear factors. And I actually know which one of them is, right? The fact that I gave you this tells me that that's a factor. So we already know one of them, we just need to find the other 2. So we do that by starting to divide. So if I divide by x minus 1/3, and I do that synthetically, we should be able to find the others. So bring the 3 down. 1/3 of 3 is 1. That's a negative 3. 1/3 of negative 3 is negative 1. Right? That's negative 3. 1/3 of negative 3 is negative 1, giving us 0. So what we have then, in terms of factorization, our function is x minus 1/3, x squared minus 3x, and minus 3. And so you'll notice that all these have a factor of 3 in them. So how about I pull that out? And again, that was the lead coefficient anyways. So it really comes down to factoring that quadratic right there. If I can find the zeros of that quadratic, I can basically find the other factors. So it comes down to solving that. And how about we solve that using the quadratic formula? So we get negative b plus or minus b squared minus a 4 times an a times a c. and all over 2a. And this will give us 1 plus or minus. I think we end up with 1 plus 4, so we end up with 5 in there, all over 2. So there's our other two zeros. X is 1 plus the square root of 5 over 2, and the other one is 1 minus the square root of 5 over 2. So in terms of factorization then, we have a 3 times x minus 1/3. Let me use some brackets here. We have x minus a 1 plus the square root of 5 over 2, and then another x minus 1 minus the square root of 5 over 2. Sorry, I'm getting a little there, but there's 1 factor, 2 factor, 3 factor, and then our lead coefficient out front. So we were able to completely factor that polynomial into the 3 linear factors that I was expecting. And in this case, what we have are all real numbers, right? 1 is rational, meaning that it's nice, and we have 2 irrational ones. This crazy 1 plus 5, square root of 5, and 1 minus the square root of 5. But again, no calculator needed because I gave you some information that we can use to pull, move the ball forward. So no calculator needed or necessary. In the last one, we were given the polynomial f of x is x cubed minus 2x squared minus 2x minus x minus 6. And one of the x-intercepts is at the point 3, 0. Right? Well, again, if we have an x-intercept, that means we have a factor. That means we have a 0 using our theory. So we're going to begin finding the other zeros, since that's what they want us to do, by dividing by x minus 3. And of course, we're going to do that synthetically. So carry the 1 down. 3 times 1 is 3. Add, we get 1. Multiply, we get 3. Add, we get 2. Multiply, we get 6. Add, we get 0. So there we have it. So we basically have, at this case, f of x is x minus 3, x squared plus x plus 2. And so the remaining zeros that we got to find, since we got to find them all, are coming from that trinomial there. So we'll solve it. And again, how about we just use completing out of the quadratic formula. So -1 plus or minus, we get 1 squared minus a 4 times an a times a c. And here we get -1 plus or minus, I think that's going to be -7 all over 2, right? That's an 8, yeah. So we get -1 plus or minus I squared root of 7 over 2. So there's our other two zeros. So one of them is 3, one of them is -1 plus I squared root of 7 over 2, and the other is -1 minus I squared root of 7 over 2. And since all they asked for were the zeros, that's all I'm going to give them. So 2 complex, they're conjugates, and 1 nice real rational one. All right, so that is ways that I can give you a quiz question without you constantly having to turn to your calculator. I'll just either give you the graph, I'll tell you we have a 0, or I tell you we have an x-intercept, and that pretty much gives you what you need to start dividing by so that you can start breaking down the polynomial and getting all your zeros or getting all your factors or whatever the case might be. All right, so there you have it. So one more round of, how dare I say, interesting problems, but we'll do that in another video coming soon.